Throughout this textbook, you'll find equations that may be written in the form AU squared plus BU plus C equals 0, where U is an expression of the variable we're solving for. Such equations are referred to as quadratic in form. Strategies for finding solutions to quadratic equations can be extended to solving equations that are quadratic in form. So a quadratic equation is just squared, correct? So this example here, I don't know if my screen is big enough to really see today. I don't know if you can see this, but it has a 6th power. Is that a quadratic if it has a 6th power? No, quadratic is 2nd power, highest power of it. So the 6th power is not a quadratic. It's not. But the cool thing is we can rewrite it so it looks like a quadratic, and then we can use the same methods we use to solve quadratics to solve it. And to do that, we're going to use what we call substitution. And usually we use the variable u. You don't have to. It's just kind of tradition to use what we call a u substitution. It doesn't have to be u. It's just, like I said, tradition. Okay, so I'm going to take my 5x to the 6th, and then I have 8x to the 3rd on the other side, so I'm going to move that over. I have a 4 on the other side, so I'm going to move that over so that this is in a better form to make this look like a quadratic. Now, a quadratic has to be squared, and it's a 6th power and then a 3rd power instead of a 2nd power and a 1st power. So what we're going to do is a substitution. We're going to use a different variable instead of x. I'm going to use u. Really, the variable doesn't matter. It's just use what we usually use for whatever reason. So u, I'm going to say equals x cubed. There's my substitution, is that u equals x cubed. So now, the equation itself still is not a quadratic. It has x to the 6th and x to the 3rd in it. But we are going to replace our x's with u's. So if u equals x to the 3rd, then wouldn't u squared equal x to the 6th? Does that work? So that gives us 5u squared plus 8u minus 4 equals 0. And now we can solve it like a quadratic. All right, what are some of the methods we have that we can use to solve quadratics? Factor, that's usually my favorite. If it doesn't factor, then quadratic formula is usually probably the best alternative, right? I don't know if this factors or not. This is an ugly problem. We not only get to practice solving a quadratic, we get to practice solving an ugly quadratic and see if we can factor. So I'm going to use a little method to see if we can factor this. I don't know if you've learned this from other teachers or not. And I know teachers have different ways of showing factoring. And there's a tricky thing out there that I've never learned, but I'll just show you what I usually do. So 5 times negative 4, and this is my little thought bubble over here. I have 5 times negative 4, and I'm going to get negative 20. So I need factors of negative 20 that add up to 8. Factors of negative 20 that add up to 8. So when I say factors of negative 20, we've got 5 and negative 4, or negative 5 and positive 4, but those would add up to 1 or negative. What other factors does 20 have? 20 and 1, but right, good. So 20 and 1, you have one of them negative, so you either get 19 or negative 19. But the one that you guys are coming up with, which is good, is like if we did a positive 10 times a negative 2, that would give us 8. We want that middle term to be an 8, so that's what we're going to use. So then we can rewrite this. We can rewrite our whole thing as 5u squared and negative 4 at the end, but instead of the 8u in the middle, we're going to replace it with 10u minus 2u. Does this seem familiar? And then we can factor by grouping. So is there a factor that will come out of this group biggest stuff we can divide out of 5u squared and 10u? 5u. Good. And then we're left with u plus 2. That seem right? Okay, what can we factor out of negative 2u minus 4 so that hopefully we get another u plus 2? What? Negative 2. Yes, perfect. So if we take out a negative 2, that leaves us with a positive u. And a negative 4 divided by a negative 2 is a positive 2. These should match. If they don't match, then this method doesn't work.
And then you add 5u.
We put these together. So we have 5u minus 2 together. It's like we're factoring out the u plus 2. So we're taking this one out, and we're taking that one out, and we're left with those. Yeah, so this is called factoring by grouping. All right, so now that we have it factored, it shouldn't be too hard, right? We're just going to take each of our factors and set them equal to 0. So 5u equals 2, and then u equals 2/5. And then we would do u plus 2 equals 0, so u would equal negative 2. Now, what's our goal here? Are we trying to solve for u? What are we trying to solve for? X. We just solved for u. We didn't finish the problem, we didn't solve for x. But the good news is, we can still do another step. We can plug in our substitution back in the other direction. So where we have u equals 2/5, remember earlier we said that u was equal to x cubed? Let's just replace our u with an x cubed. How do you solve a problem like this that just has like an x constant with nothing else in the way? What's the inverse of a cube? Cube root. Perfect. So x can be the cube root of 2/5 or the cube root of negative 2. Is it okay to take the cube root of a negative?
Yes.
Yes, it's fine, because cube root means it's something that multiplied together 3 times to get that number. If you have 3 negatives multiplied together, then you would get a negative value. So a cube root is just fine of a negative. There's our solution. We used a quadratic method to solve a non-quadratic problem simply because we could make it look like a quadratic. Kind of crazy, huh? Let's do the next one.